do you want to introduce yourself? It's our first Antrea live stream, so kind of excited for everybody to be here. Why don't you all introduce yourself? Then I'll introduce myself. Then we can get started.
Go ahead, Yash.
Sure, yeah, I'll go. My name is Yashbhutwala. I'm currently working at a company called Staked. We run a bunch of different blockchains for different cryptocurrencies and provide staking services for our customers. But I've been, sort of in the Kubernetes space for a while, and Jay and I used to work in the past at Synopsys. That's me.
Cool. And Arun.
Yeah, sure. Hey, everybody. I'm Arun Sriraman. I work in the Vmware SD-WAN space. So the product essentially allows you to connect multiple locations, edge locations to your data center and cloud. And I've been been involved with Kubernetes for quite some time now. And like Yash, worked with Jay in the past and currently in some form or way. So I working at VMware too. So.
Yeah, me and Arun over here at VMware, we work on. I'm Jay. Most of y'all probably know me that are watching this stream, anyways, because I'm pretty active in upstream networking, SIG network related stuff. And yeah, me and Arun are here at VMware. We work on a whole bunch of networking related stuff. So hopefully this is our new stream. So in case we're getting logistics and everything set up, but folks can type comments in the inside the little comment thing, and we'll answer them. This is partially office hours, and it's so like if you have Antrea questions about releases and stuff, depending on who all is here, we may be able to give you some really interesting answers. It's also partially a hack session where we're going to be able to go through things and look at stuff together. And so it's kind of a little bit of both. And I see Yang is here, so it's great to see Yang. So yeah, if folks want to jump in, we're in the K8's upstream Antrea channel. So Yang, what's up, Yang?
How's it going, Jay?
Great to see you. Cool. So yeah, good. So we just got started. We just did intros. So yeah, I'm Jay, and my friend here is Arun, and Yash is here. Yash is also my buddy. Like the purpose of this stream is for us to all get together, look at stuff going on in upstream networking, in the SIG network area, in the network policy area. So it's great that Yang is here. He can maybe give us an update on that, and do a little bit of hacking and hanging around and learning about how Antrea works. And Abhishek is here. Abhishek with your telescope is here. Okay. So and Abhishek used to be friends with Arun before I was friends with Arun. So
we are still friends.
We are still friends, yeah.
They're still cool. So, Abhishek, you want to do a quick intro and Yang, you want to do a quick intro for yourselves?
Okay, maybe I'll quickly start. Hi, this is Abhishek, and I've been part of the Antrea team since the beginning of Antrea. So I've done some of the network policy part and the Antrea native policy part design along with Yang, and Yang will probably talk more about it.
Cool. And Yang.
Hi, my name is Yang, and I've worked alongside with Abhishek on the network policy side since of Antrea. And I've been, a part of the project Antrea, I think over a year now, and yeah, we're glad to be here.
Cool. Okay, so I was thinking what I would do. So me and Arun were just playing around with clusters. We had an infrastructure panic for a little bit, but I think I figured it out, Arun. I'm going to give you an IP address, and you can SSH into it unless you have a running cluster right now. And it's an internal IP address. So I'm just going to give it to you in the StreamYard chat, okay?
Okay.
And you know
get everything up and running by the time you give me, so we'll see.
Okay, so it's in there, and you know the username and password to those machines, right? Okay, so Arun is going to show us how K8sNetlook works in a little bit, but first, Well, I don't know. Abhishek or Yang, do you either one of you want to talk me through what's new in 1.3.0, which is the newest Antrea release?
We might need to pull the release notes because I was out of office last week, and Yang has just come back from his paternity leave.
You just got back. I know. Okay, I know what's new. Full FQDN. So I'm going to show folks how FQDN works.
Oh, you're talking about the 1.3 release in the past.
Yeah. So I was just playing with this and showing Arun. So this is kind of cool because I remember when the first FQDN, we were trying for a long time to convince the upstream SIG network folks to get FQDN working. And I don't know where that landed because I kind of started focusing on other things. But as far as upstream, where are FQDN policies, Arun? I'm sorry, Abhishek and Yang. Like,
yes, well,
where
the
did that
upstream
land?
side of things, there are a couple of guys from Google who were driving the FQDN policy effort. And they, I think, have merged some of the controller part in their GKE repository, and that's something that they want to donate to upstream. But in terms of the KEP itself, or how we want to achieve FQDN policies with network policies, that is still not agreed upon. So, and I think the upstream community is looking for volunteers to drive this effort into the community. So anyone who's listening or who's on the call here wants to work towards that, feel free to join us on the SIG Network Policy API meetings on Mondays. But yeah, as part of that, we wanted to fast track that in Antrea. So Yang had a significant work that he did for the FQDN along with Grayson from the Antrea team.
Yeah. So that's Yang, you got anything to add to that before we dig into some live stuff?
Yeah, so I think it's been a while since I was developing this. I think the FQDN policy sort of like code was ready around 2 months ago, and then there was some improvements. But at the time that we implement this FQDN policy, I think the challenge for this to being upstream is that there are two flavors of this, right? So if you think about FQDN policies, people apply FQDN policies in two flavors. One is that they have a specific FQDN they wanted to sort of like allow or block, for example, Google.com or Facebook.com, right? And the other very common use case is a wildcard use case, where people wanted to say, I don't want anything coming from that Facebook.com to access my workloads. So people will put something like star.facebook.com. And this is on the upstream side. This is a more difficult use case to solve, because if it's a static FQDN, you can always sort of like do a DNS query and resolve the FQDN to a specific address. But for wildcard cases, it usually rely on some mechanism in the CNI itself or the implementation itself to do some sort of like proxying. For example, we actually wanted to look into the DNS response and to see if it actually matches one of the wildcards that users specify. And then after that, do some sort of like a data path rule realization and decide, whether the packet should be allowed or not. And I feel like this is, the major thing that's also blocking the FQDN to be moving forward in the upstream side, is that there's a lot of implementation specific bits in the FQDN policy itself.
So where's the proposal from the Antrea side on FQDNs? Is there a proposal doc that you all made? I remember the Google one. We demoed it live in the upstream network policy meetings, and then I know here's how they're implementing it over it.
Yeah, those are. I guess those are just the manual on how you can use an FQDN policy. But
let's make one as an example and see if we can go from there. What's up, Luther? It's good to see you. I muted you because there's some background noise, but now I'll unmute you. How do I unmute you? I know Luther and Scott Rosenberg just joined us, so that's cool. I appreciate you all coming. Let me see here. So I'm in a cluster, kubectl get, and if I get my cluster network policies, network policies. I don't know if I have. Yeah, I actually have one. So let me delete this. kubectl delete cluster. Is there a short term for this? Do I have to do CNP every time?
I think the ACNP, if I remember.
I think I tried CNP and it didn't work.
ACNP.
ACNP. Okay. Okay, cool. So there's nothing in there. So Antrea has this concept of cluster network policies. Now, Abhishek also can tell you all about there's this whole cluster network policy thing going on. Well, Young and both Abhishek have worked hard on that. And there's a KEP for that. And Abhishek, if you want to put the link to that KEP in here, I can link folks to that. But we're looking to get all the Antrea cluster network policy stuff as much as possible, at least, into upstream over time, at least, if we can, at least whatever makes sense. So let's see. So if I go in here and I've got an FQDN policy here, right? So folks, look here, you can see I've got a policy. It's got a priority of 1. Does that mean it's high or low?
That means it's high. So so it's basically, think about it in terms of like, how would you prioritize your work items, right? When you think of certain work items are being like highest priority, you would say it's a P0 item. So lower the number, higher the priority.
Okay, so this will override any allow rule. So if I had an action allow, right? So if this was allow, this would get overridden by this policy, right?
So if you have this, so we're looking at the one on the ACNP FQDN one.
Yeah.
Yeah. So
let me know if this is too small.
If it's priority 1, then you're overriding any other policy instances that you have in your cluster, because as long as they map to the same, as long as they apply to the same set of pods, this higher priority CNP will take more precedence. So in this case, your drop rule for the foobar.com will have the highest priority.
Okay, cool. The drop rule for foobar will have the highest priority. Okay, cool.
That's the only rule that you have in your cluster right now. So
yeah, obviously, yeah. So so if folks want to go and try this out and play at home, I have this directory here, and it's got the policy. So if you go to JUnit100 K8s prototypes and AntreaLIVE 10/27/2022, you can go in here and you can copy paste this. And this same directory, you can go into this same repo and you can go into kind, and then you can go to run this kind local up script, and you can just run it with the Antrea flag. And if you run it with the Antrea flag like this, where is it? Cluster, like that. You can just literally like run this command, and it will generate a multi-node kind cluster for you. So kubectl get nodes, each of which is running Antrea 1.3.0. So if you want to play at home, it's not hard. So, and then there's a kubectl create -f. One other thing that I'm creating inside of this same repo, which is there's a smoke test directory, and you can like see this Nginx pod service. So if I do cat smoke tests Nginx pod service, that's just basic smoke pods, right? Like a BusyBox container, and I'm labeling it with app Antrea, and you'll see why that's important here because it's a match label for that. So I want to block stuff like Young was talking about, right? I want to block things. So kubectl get pods, I've got this running, and I go down here and I want to make this network policy. So let me exec into this pod. Okay, so I'm in here, and let me wget www.foobar.com. Okay, so it's giving me an error 403. That's not a problem, right? It means it's able to get there. It's just that I'm going to a random website. So I'm not returning anything. So I'm able to reach foobar.com. I'm able to resolve the IP to 173.23 1.209.3.4, make a TCP connection to it, connect to the web server. The web server says, you can't access this resource, but I see you and I can hear you. Okay, cool. So now I can kubectl create this FQDN policy, right? Oh no, what did I do? I forgot to put the file. Here we go. Okay, so now I made this policy, and this pod's policy is matching the label of that pod that I created, right? So this match label is saying, I want to apply this policy to this specific pod so that this pod drops all egress traffic, so that the CNI Antrea drops all egress traffic to this FQDN, right? So then I'll go over here, and now I can do a curl or wget www.foobar.com. Let's see if it works. Wait, I didn't. Oh, that's weird. It worked. It shouldn't have worked. What did I do wrong? wget foobar.com. Oh, maybe I did it in the wrong namespace. kubectl get, what is it, ACNP? Okay, it's there. I'm getting a forbidden here, but I have this policy. So why do you think that would be the case? I wonder, kubectl delete cluster network policy. Try to delete it and see. Okay.
Could you double check the pods again that you exected into?
Yeah, I might not be in the right pod. Oh, I know why. I did a Docker exec into one of the nodes because I was trying to show Arun something. So let's try it again. I think it'll work this time. wget.
But you deleted policy.
Yeah. So let's watch it work first.
Okay, cool.
www.foobar. Thank you for that. Yeah, you're right. I was going into the wrong thing. Okay, so I can get in, and the policy's gone. Now let me create it. Let's try one more time. Okay, boom. All right, now run the same command again. Okay, and now you can see it hangs. Okay, so thank you, Yang, for realizing I totally execed into something that was not a container. So, all right. So we're in. So we're able to block traffic through FQDN. So this is cool. Just so people understand the difference here, the normal network policy API doesn't. So if I go to network policy API Kubernetes, if I go to the docs, if I go to the existing docs, you can read about these if you're new to this stuff. And like, we support matching pods and then blocking on pods and blocking on namespaces. And you can do some blocking on CIDRs and stuff, but you can't block FQDNs using the Kubernetes API. So this is something you need a custom CNI provider to do, like Antrea is doing for us. So really excited about that in 1.3.0. If folks want us to show anything else, feel free to add questions in the chat. Thanks, Yash, for taking notes. Yash is taking a bunch of notes over here. So, and the cluster network policy, and it looks like Abhishek. So Abhishek, you can add them. Y'all can add the public stuff in these in the YouTube comments in the thread so folks can see them. And then I can do this. See, I can pop up the little thingy on the bottom, and it looks cool.
That's cool.
So yeah, feel free if you all want to add comments and links in there, go for it. So yeah, and then hi everybody. Let's see if this works. Okay, cool. Next up is Arun. So Arun, we have a couple of options. You can use a cluster that I've given you. We're going to look at this tool called K8sNetlook. So K8sNetlook is like a network diagnostics tool that Arun was hacking on for a while that allows you to sort of, anytime you're in a customer environment or whatever, and you want to see why networking isn't working, usually the first thing you do is you try to curl from a NodePort. Then you try to curl from a ClusterIP to see if basic stuff's working. Then you try to see if DNS is working with the API server. There's this list of things we all do that are kind of intuitive. He's kind of automated all that over here at K8sNetlook. So he's going to show us that working, I guess. And now, how do we want to do it, Arun? What's the plan here? Do you want to get into my cluster, or do you have something? I think you're on mute, my friend.
Yeah, I think we all speak on mute all the time. So I did take a look at the cluster that you gave me, but I might not be able to get NetLook on there. I'm still figuring out how to get into your cluster completely. So let me share what I have.
Okay.
But we need to see if things are running as they are. Just give me a sec.
Because you can SSH into the nodes. I could, if you start we can SSH
Is
into the
there
nodes.
an easy way to get files onto the nodes, wget? Because I know it's foot on Linux. So
oh yeah, is it Photon? There should be. We should be able to yum install wget. Let me see. So I'll do kubectl. Let me start a tmux session. So tmux new -sj. Okay, now let me do. I can share this screen while we run so people can see. Here we go. So if I share. Window, share my terminal. Okay, cool. So now I'm sharing my terminal. So if I do, so for folks interested in VMware Tanzu, this is a VMware Tanzu cluster that's running. And we run Antrea by default in VMware Tanzu, right? So if I do kubectl cluster info, you could see kubectl get nodes. Okay, so I'm in a management cluster. And so here's my 3 nodes. So Arun, I can SSH into one of these nodes by doing SSH cat v.
Mm-hmm.
And if you do tmux-a, you can join me in here. I don't know if you use tmux, but so if I get wget, okay. So if I do yum, can I do yum install -y wget? I don't know. I assume I can, but I don't know. And then let's see. SSH.
Did that actually finish? Oh, no. Okay.
I think it's just hanging out. So we can try other ideas. So does curl work? Yeah, we do have curl. So if I do curl-o, that should work, right? If I do curl-o www.
Let me get your command file.
So if I curl,
yeah, you should be able to do a -- output and give it a file name.
Okay, so do you want to just curl? Yeah, I mean, that works, right? So do you want to just curl K8sNetlook onto this cluster and run it?
Yeah, let's try.
Okay, so just do tmux space a, and you can get in there.
Man, you're asking me to get on a tmux session.
Oh, wait, we got wget. It did wget. It did wget. All right, here we go. So, all right, so we're able to get. All right, so now, how do I get K8sNetlook? K8sNetlook.
That should be a single command.
Yeah, that's not hard. Wget. So, Arun, you presented this at KubeCon. How did it go?
It went well. I think there were about 500 plus people who were both live and virtual.
Okay.
So I'm happy. And I heard good feedback that it's going to help people figure out networking issues without losing all of the hair that they have. So
let's, okay, so you're set up. So you've got K8sNetlook on here. So what do you want to do now?
Is there a kubeconfig on the node that you can export to?
Yeah, are you in this session with me?
I am not. So let me log in.
SSH into that jumper. It's 10.92.2118.96. And then I can, meanwhile, get a kubeconfig for you. So actually, we should have a kubeconfig on there. I guess this is the first time I've ever tried to do this. find/-name. I don't know. I mean, it's a kubelet, so we might have a kubeconfig on here. No, okay, but I can get one. Let me exit out of here and then cat home.kube-config. Okay, so there's my config. Now, I guess I can SCP that, right? So I can SCP home.kube. Let's see who's better at like typing kube SCP commands by hand.
So I finished doing that on TKG MGMT VCMD0 node. So
okay, so we're in the wrong node here.
So I guess you're in a different node. Not wrong, but different nodes.
Not wrong, just different. Okay.
Which one are you on?
I could just copy it. What is the what is the IP? IP.
No, just do SCP that file to to one of the nodes.
Yeah, I'm on. Okay, SCP. I'm gonna do cap v at here :/temp, right? So I'm gonna copy the file. Okay, so there's your kubeconfig, right? So your file is now in cat/temp config. Oh wait, I got SSH back in, and then I'm gonna let you go. Then you're free. Okay, you got everything you need. You got a kubeconfig.
So MGMT VC control plane. So let me log into that node next.
You don't need to log in anything. You just log into the jumper.
I'll just tell you, and you can execute commands on it. Oh, that's jumper? Okay.
Just log in the jumper and do tmux a, and you're free. You're in the node.
Give me a sec.
It'll be easy. Don't worry. I promise.
Maybe I'm not on VPN. SSH? Just give me a sec. Yeah.
All right. Meanwhile, I can try to start doing stuff. So K8sNetlook, and I can do -config.
Yep.
You still do those old school single dash command line options, huh?
Yeah. Okay. Try host first and see if at least the host ones pass.
Okay.
Host and then the config part after. Yeah.
Okay, here we go. It worked.
There is a problem.
What's the problem?
Let's try user.
Why don't you explain this to us really quickly, and then we can try the next thing. So what is this output? Yeah.
So what K8sNetlook does is it essentially has a bunch of checks built into it. It goes in and tries to execute a bunch of not just commands but also network traffic. If it's running on the host side, it's going to just be a process running on the host, and it's going to run some ICMP packets, DHCP, DNS packets around here and there, and figure out how the overall network connectivity looks like from the system in relation to Kubernetes, of course.
Okay. So this is a healthy cluster. I've got Antrea agents running on every node. I've got a controller.
Yeah.
And so what do I do now?
Right. So now we need to see what's going on, right? And the tool itself does need some permissions on the OS level to be able to create packets and send them out on sockets. So it does need a net raw socket permission when it's running. So it might be, it's probably just a pseudo problem. So if you run a -debug at the very end, it'll also tell you what's going on when each of the checks are being run.
Okay, let's try that. So if I do this -debug. Okay.
Right. Cool. So you can see that it's actually able to talk to the API server and run live zcheck and health checks for all of the API components.
Okay.
It was able to, what happened there, it's not able to open an ICMP socket to run ICMP or ping tests, and that's because its operation is not permitted. So you need to run this tool in sudo or...
oh, that's the only problem is I didn't run it as root?
Yep.
Oh, that's it. You should have just told me run it as root. Okay, so we run it, so it's working. So okay, so we're able to do it. So this is cool.
At least the host side checks look good, right? So it's able to talk to the default gateway from the host. It's able to talk to the Kubernetes API server.
Yeah.
It's able to also run service checks, right? So this Kubernetes API server endpoint IP, that's going to be the ClusterIP within Kubernetes. Yeah. So that's what is backed by either KubeProxy or KubeRouter or one of the other implementations out there. Maybe in future Kaping, right?
Yeah.
So
thanks for the Kaping shout out.
Yep.
I didn't know that was coming.
So
that's the next episode. That's why y'all should come back, because we're going to talk about Coupling next time. Okay. Yeah.
So it is going to run the ICMP check on the Kubernetes cluster IP. So which means it's also checking service IP pathway, which is host to service IP to pod.
Okay.
In some form or other.
So this is confirming that it. How is it checking this? Like, what is it? What are you doing to check this? Are you making a pod?
Go further up. Yeah, go further up. So this is all running from the host.
Okay.
So it has got the service IP from Kubernetes because it has a kube config. It's able to, so it does a HTTP call to see what the API server returns, and it returns a 401 because that's not there. It's forbidden. We're not using an authentication token or a bearer token, but that's good because it's a pass test from a K8sNetlook perspective.
Yeah.
And then what it does is it tries to get all of the endpoints that are backed by that service IP. So you have 3 control plane endpoints, 3 API servers running somewhere.
Okay, so it's going to the cluster IP that forwards me to my API server, and I've got a 3-node cluster.
Right. So the first test, if you look at it,
okay. So just for folks that are playing at home, that are maybe, because we're going a little fast, I just want to make sure people get to see this. So if I do kubectl get nodes, you can see we've got 3 control plane nodes, right? So what Arun is talking about here is that these 3 nodes here correspond to those 3 control plane nodes, right?
Exactly. Yeah. So if you scroll a little further up, Jay, and so the first one that you see there, from host running kube service IP connectivity check. So that's going to the service IP. And the next one that you see, which says running kube API server endpoint IP connectivity check, which has those 3 IPs underneath it. And what it's doing is first it's trying the service IP, and then it's trying each endpoint individually to see if all of them are healthy or not.
Okay.
And if any of those control plane nodes don't respond, you're going to see the pass fail. Okay,
cool. So this is the cluster APIs. Okay, yeah, go on.
Right. And then it's going to talk to the API server and actually get its status that it knows.
Okay. So each one of these arrows is like a different check.
Yep.
Okay, cool. Great. So what is all this stuff?
That's the API server's live Z endpoint, right? The health Z endpoint for API server runs a bunch of API server checks that's already in upstream Kubernetes. So you can do this today if you want to hit the Kubernetes API servers.
These are just the live,
and health Z. Yeah, and then it tells you if all of the plugins are loaded and the API server is healthy in some form.
Why do they all say post start hook after them? What is that? That's the name of the endpoint?
That's probably the name of the method that's returning the check. So Kubernetes has a bunch of hooks that tie in to tell you if each of these controllers and feature gates are enabled or not, right? So CRD informer, bootstrap controller, RBAC stuff, everything looks okay. This is what it says.
Cool.
You can do a -S at the end of the command. Remove debug and say -S. Oh, sorry, not -S. Yeah, silent. I forgot to use the short form as well. So just say silent. Yeah.
Did you use Go flags? Like you didn't get Cobra, you just used Go flags?
Yes, I used Go flags.
You didn't want to add that extra dependency?
You know why? 1 is dependency, and 2 to keep the size of the file as small as possible. So right now this binary is about 8 MB, and I'm in a process to get it down to 2 or 3 MB if that's possible.
A meme is here. He said kaping. Okay. So you're just trying to make the smallest binary ever, so small that you can't even use fancy Cobra command line options. Okay.
Right. You see, I'm working on the SD-WAN side now, so it's all packet level processing and bandwidth and line rate. So we got to keep things small.
Oh yeah, okay. You're one of those. Okay.
Yeah, if people want to automate
all your code in C nowadays, okay.
This is still Go, but yeah. So if people are interested to automate using this tool, they can use that as silent option and then get a JSON blob.
So this is
do whatever with it.
So we need to build a Sonobui plugin next, right? So next thing you need to do is we need to put this into Sonobui and then have like a Sonobui K8sNetlook plugin.
Yeah, we could do that. So K8sNetlook itself can be run in multiple ways. It can be run as a binary on the node where there's a problem, or on the node where a pod is exhibiting an issue. You can also run it through a Docker container. There is a Docker container that's uploaded with the binary, so you can run that, similar size. Or you could just run it as a Kubernetes job. So there is a YAML spec
So I can run it as a
GitHub repo. You can, and give it a node selector so that it lands on the right node where the problem.
You want to give me that example of that, and I can try to run it for folks?
Sure, actually,
Paste it
somewhere. Can see it on GitHub.
Okay, see it on GitHub? All right. GitHub, I'm Googling right now, K8sNetlook pod. All right, so K8sNetwork problem detector. And then I go K8sNetlook. Can I just do pod?
Examples? Can you just do examples? Yeah, you can do pod here through the binary.
The binary is smart. Okay, I see the raw file. I'll get it. Okay, let me get back to my.
So the idea why I don't recommend running it as a pod within the Kubernetes environment is because you're debugging a Kubernetes problem, and now we want to deploy another new deployment into Kubernetes.
Yeah.
It sounds weird. So, I mean,
okay, you're right. It works.
You don't want to have the monitoring and the debugging tool running in the environment that you're trying to debug.
So then what do? You exec into it, -t.
Wait,
exec into it.
Already deploy it, so it's not going to run, right? So you need to change a couple of things in that pod, in that spec. So delete it.
Okay.
kubectl delete -f.
Okay.
So what you need to change is if you go at the very bottom.
Yeah.
Yeah. The command is there, right? So that needs to be edited to whatever command you want to give it.
Okay.
And you need to change the host name to represent the host where you want this to run.
Okay. Host.
That's the node selector at the top. Yeah.
Okay, so I got to put the IP address of. All right,
it's
not
the
IP
host
address,
name label. Yeah, it's the host name label.
Okay, so
yeah.
kubectl get nodes.
Do you want to fire a couple of pods first? Do we have pods in that cluster?
Yeah, we have core. Every cluster always has core DNS, right?
Let's deploy a couple of application pods.
A couple of non-core DNS pods.
Yeah, because core DNS will anyway get checked by K8sNetlook. Irrespective
oh God, this isn't. Okay, but wait a second. What do I do? What's the host name? I have to edit this node, right, to get this. So kubectl edit.
Not edit. You can just say get node so YAML.
What do you want me to? Oh, I have to.
You should have that, right? Isn't there one? It should be there.
Yeah, they annotate it. Oh, it's just the name. So the host name is always the same as the regular node name. Okay. I didn't know that. I don't know.
Well, it depends. It is the name that kubelet registers the node with. So if you have a host name override with kubelet, then yeah. So this looks good. So your host name and what kubelet registers on your cluster looks good.
Okay, so I'm going to delete K8s-f K8. Oh, where is it, everyone? Run K. Here it is. Okay, I'm deleting it. Like you told me to delete it, I'm deleting it now. You want me to not run core DNS? No. You want me to run something else? You know what? I already have.
Run a busybox and a couple of host names. Okay. There's a host names example on Kubernetes documentation, right? It gives you the host name of the pod.
I have my
for debugging purposes, or Nginx, whichever.
I have my own examples. Okay. Let me see here. Hold on, where is it? Smoke test. Hold on, let me get him. All right. Here you go, Arun. I'm gonna make this. I'm gonna run. Here we go. All right, I'm going to try this one, and then if you don't like this one, I'm going to do the one you wanted me to do. I think this is fine, because we use this in the other example, right? So this gives you a busy box and an Nginx. So this should give you everything, and it's got a daemon set on it. So
sounds good. And how many Nginx pods? Let's have multiple.
Okay, multiple Nginx pods. Multiple
to make
Nginx
it
pods. Yeah.
to make it a little more realistic, you do have normally.
I think this is a daemon set because I think I usually do a daemon. Oh, it's a deployment. Here we go. There we go.
Wait, is that a Docker rate limit issue?
That's it's a Docker Hub rate limit issue because we're inside of a VMware data center right now. So let's see if this works, and then maybe we'll get lucky. Maybe one of them will pull down. If not, I can change to using our hardware proxy. Over at VMware, we have a hardware proxy that we use. So can we see if the pod basically works though first? How do I test it? So
you need to give it a source pod and a destination pod, right? Which are running on the container network.
Okay.
If we have to, we can give them. We can try that.
Source and a destination, and then what is it going to do with the source and the destination?
So the assumption is that you have a problem at the source or the destination, but app A is not able to talk to app B. So what K8sNetlook and everything looks running right from a Kubernetes perspective. So what K8sNetlook will do there is try to run a bunch of checks as if it's running within the pod. So it uses the network namespace of the pod on the host, and then think of it like running a sidecar container, but not really through Kubernetes, just outside of it.
So
Linux namespaces.
So I switched over to this so we could draw this out for folks. So I've got, say, a node here, and I've got a node over here.
Mm-hmm.
Okay, and if I'm running K8sNetlook in a pod, maybe this is running on my third node.
So let's talk about how you want to deploy K8sNetlook first, right? So are you talking about it in terms of running it as a binary on a host or as a
let's
Kubernetes?
Let's think about this example that we're doing right now, where we're talking about running it on a pod. Because since we're kind of at that 45-minute mark, I want to make sure people get to learn something other than watching me edit YAML. So that's cool. We got it. We gave them the basics, and now let's show them something about how it actually works at a higher level.
Yeah. So when you deploy this K8s API, you're going to specify a node selector. And the idea is when you choose that node selector label, you choose the one where the source pod is running.
Yep. So I selected N3. Okay. Let's say, right? So I selected N3.
You'd normally want to select N1.
Okay. Right? So I did the wrong thing.
You want to test pod 1. Yeah.
Okay. So if I want to test this thing, this is good. I didn't realize that. So if I want, I can drag the letters one at a time. I'm not good at Miro. Oh, here we go. Okay. So normally this is how you would do this.
Right.
Cool. So I would normally do this, right? Cool. And then, so I'm running K8sNetlook on here, and then what does it do? Does it exec into this pod?
It does not exec per se. What it does is that K8sNetlook first runs as a process within the host network namespace on that host.
Yeah.
And it does a bunch of host checks that we saw.
Oh, okay.
So Kubernetes networking, the way I see it, you need to look at it in three terms: pod-to-pod connectivity.
Yeah.
Pod to host or pod to service, and then service to pod and external, right? A bunch of these combinations and permutations.
Yeah. So we got services.
If you talk about it in the networking terms, it's east-west versus north-south versus inbound, outbound, right?
Okay.
Yeah. So K8sNetlook runs on the node and does a bunch of checks.
Yeah.
And then what it does is, given a source pod, it's going to use Linux network namespaces and Linux commands to go into, or rather switch the process into running into that particular process, the pod's network namespace.
Okay, so this is doing like a netNS lookup thing over here.
NS enter, for example.
So you're NS entering into the network namespace, and then how do you look up like the pod name from the containerd information?
Right. Exactly. Okay. So you give K8sNetlook kubeconfig, so it can get information from Kubernetes. So it gets the node name, the container ID, and the runtime, and then it goes to the container runtime down there and tries to get the exact proc ID or process ID to use to figure out which network namespace it's running in.
Okay. Okay, cool.
And then it logs in there and runs a bunch of these checks. So when it's in there and it's running, it's as if the pod is sending out information or receiving information.
Mm-hmm.
So it's like a sidecar container.
So then this is essentially a sidecar to the pod, and it's on the host. It's like a host. It's not really a sidecar because it's in a different namespace, I guess, or maybe you call, I don't know. I get it.
It's running in, it's able to run in both namespaces. It's running some of them in the host network namespace. It switches itself into the pod's network namespace and runs it.
Oh, that's fancy.
The advantage is that it doesn't, it's not known to Kubernetes. So it's like a sidecar if you think about it.
So it's actually running processes inside of this namespace and in the host namespace. Okay.
Exactly.
That's cool. That's really cool.
Yeah.
I think we're close to time, Arun. Does anybody have, I know Jiunjen, you're here on YouTube. If you want to leave any Antrea announcements, or Abhishek, or any other folks that are on this call, now is the time. Otherwise, and you, of course, too, Arun.
So, Jay, the KubeCon talk has a good demo that goes through all of the checks, all of the pods, and how the tool is built, the architecture, and what all checks it does, how it does, as well as how to debug a Kubernetes problem in general, and what to do. So do take a look at that KubeCon talk.
Yeah, I mean, let's do another session like in a few weeks or something, Arun. Like, this is our first Antrea Live, so it's like, we were just playing around, but if folks are interested, or even, whatever, people are still learning, so maybe nobody understands what to ask yet, but maybe we do a deeper dive and you could show us how it actually works under the hood.
Yeah, definitely.
Cool.
It can work with any backend, entry or otherwise.
So can I Google this? KubeCon K8sNetlook?
It should come up, yeah.
Okay, so it's over here, but it's not on the internet yet, right?
The video is not on the internet, but the slides are on it, so you can get a lot of commands and diagrams and pictures on the PowerPoint slide.
Okay, so the slides are here.
Yeah, whatever you drew there, I think there are some pictures.
There are some pictures but they're not as good, right? Okay.
I'll leave that to you.
All right. Okay, here we go. This is beautiful. Look at this. Awesome. Here we go. Cool. So this is cool. Thanks for helping me out. Everybody, thanks for coming. Yash, thanks for showing up. Yash, I don't know. I know, Luther, you showed up. I don't know if you have anything going on the CNI end that you're excited about.
Well, you just want to talk about CNIs? Or do I have to talk about Antrea?
I mean, well, it is the Antrea live stream, and you did tell me that you were going to get it up and running on Rancher pretty soon, right?
I am. I'm going to get it up on Antrea. I just need you guys to support privileged containers and support IPv6. Get it going.
All right, we're on it. Okay, we're
on Windows, by the way.
On Windows, sorry. He's talking about Antrea on Windows. And so, by the way, speaking of Antrea on Windows, we have a couple of bug fixes. I'm going to bring those. There's a couple of Windows bug fixes. One is related to reboots. That's on its way. Host process containers are coming along, and AntreaProxy, which is a big thing for Windows, we have PRs now for AntreaProxy, which is a replacement for AntreaProxy, which is a replacement for the KubeProxy, and there's NodePort, ClusterIP, and whatever. There's like the third PR. There's like 3 or 4 seminal PRs, and those are all in.
Wait, hold on. Can you give me an elevator pitch on why you're ditching the KubeProxy?
Well, we got some Antrea folks in here. Abhishek, what's the most exciting thing, or Young? Jiunjen is here. Jiunjen. Yeah, thanks. So Jiunjen, do you have a elevator pitch, or Abhishek, about AntreaProxy and why it's such an exciting new feature? I can tell you. I
think if Jiunjen is here, I think he's probably the right person to talk about it. But essentially, what we want to do is like get rid of KubeProxy and do everything with OVS with AntreaProxy, and that will also help us, do network policies efficiently. And in addition to that, it's portable to Windows as well. And I believe there are other few topics which is related to NodePort services that can be solved by using AntreaProxy very well. But I believe, again, Junjun might be a better point of contact on that. But I think, once we start handling things with OVS with AntreaProxy, there's more flexibility for us to do a lot more, and we can do more features as opposed to trying to get it done using KubeProxy. And just having to run one single proxy is easier. But yeah, again, I think I'm more on the network policy side of things.
Abhishek's breaking up, but he likes network policies. Yeah. Junjun, what's your, So for me, from a Windows perspective, it's huge because normally, like with Windows, right? Like if you think about it, like if I have a cluster and I have a Windows node over here and I have a Linux node over here, right? And I'm running KubeProxy on Windows as is, right? I have to run KubeProxy without privileged containers. I have to run that as like unless I'm using Rancher Winds. But even then, right, I have to run it as its own host process and manages that as its own piece of hardware, right? And on Linux, I'm running the KubeProxy, and that's running in a pod, and that's running in a privileged pod, right? So here it's in a pod. Sorry for my horrible Miro, but here it's in a pod. Here it's on the host, right? If I run AntreaProxy, then I'm basically I can run Antrea can manage both my CNI, right? It can manage my CNI for both Linux and Windows, and it can also manage all of my service routing and everything else all through the CNI. So it's one less thing I have to worry about. To me, like that's the biggest thing. The other big thing is that OVS, Open vSwitch, the thing that Antrea is based on, doesn't like to run that on Windows. I have to have assigned binary and all that. So once we move over to running AntreaProxy, I have all that work to set up OVS, but it can do everything, right? So OVS can kind of like handle all that stuff from me, and now I get all these benefits from it, and I don't have that extra cost of having to also run the KubeProxy, which forces me, when I do the user space stuff, because I'm running an OVS, I have to run the user space proxy, which then I can't run the kernel space proxy. And the kernel space proxy for Windows has a bunch of features that are, sort of better than what you have in the user space proxy because it's faster. So part of the big reasons for me is I like the fact that OVS now can be like a first-class citizen in my cluster managing all the networking, as opposed to half of it being Windows and half of it being non-OVS. So for Windows people here, that might make sense. For the rest of you, I don't think you care about that explanation. But here's Junjun. He's got a couple of points. So the major point is keep the whole forwarding pipeline in a single data plane. OVS, good for management, troubleshooting, maintenance. It gives a lot of also, like for us at VMware, it gives us a lot of native integrations that we're interested in. There are performance advantages compared to IP tables as well. And yes, Windows is a single data plane implementation across Windows Linux. So yeah. So it's going to make Windows networking faster with it. It's going to be great. Now, one interesting thing, I compared Windows and Linux networking bandwidth over the user space proxy on Antrea, and the performance is about the same, which is interesting for a single pod, or is pretty close. So it's not like it's really, things are pretty good right now, but yeah. All right. Anything else? Anybody else wants to share? We're kind of at that hour mark, so I think I'm going to close up otherwise. And thanks everybody for coming to the first Antrea live stream.
The AntreaProxy will be open source, just like Antrea, right? I assume you give it the same name for that reason, right?
Yeah.
Sweet.
Yeah, definitely, yeah. And hopefully we can convince people to put it into Kaping soon, so maybe I'll bother Junjun about that. But we have all these backends. We as in me. Me and Ameem are going to do it. Me and Ameem are going to get the Antrea folks to put it into Kaping, or
so
maybe to use Kaping.
In our K8s, when we boot kubelet, execute proxy, we do them all and just run them as sub processes. I get your point though, because there's also the CNI right there as well. that we do the same thing with. But having both in one, pretty slick, pretty easy to do.
We'll do a big demo of AntreaProxy soon, maybe next time. So, okay. Thanks, Luther, for coming. Luther is over at Rancher, by the way, folks. So thanks for coming. It's good to see people from different companies coming and hanging out to learn more about Antrea. And everybody, keep in touch with us on the Antrea channel, in Upstream Slack, on Kubernetes, or come find us. Well, you can find me and Luther in the SIG Windows room, and you can find Arun in Upstream Slack and everybody else here. Thanks again, Yash, for showing up and helping me run these from Staked. And we'll catch up later. I'm going to end the broadcast. Bye, everybody. Bye, Abhishek, Yang. Thanks for showing up. June, Jen.
Bye, take care.
Thanks, Jay. Bye.
Thanks, guys.
Thank you. Bye.